Alright guys, well welcome to this video lesson. This video lesson's on physical and chemical changes. So those are two different types of changes that after today's lesson you guys are going to be able to differentiate between. And then when you guys return, we're going to do a lab where you're going to do several different experiments and you're going to have to indicate whether or not you witnessed a physical or a chemical change. So anyways, it says 34, Fruit of the Loom, 50% cotton, 50% polyester, machine wash warm. You sit in the stall. When no reading material was available, Nick was forced to take extreme measures. The boy had to read the underwear band. He's hurting for reading material. Physical versus chemical changes. Last time I saw Josh, he said something about being willing to pay a high price for freedom. The boy went for it. Swimming in the ocean now. Chemistry is the study of, you guys should know this. What is it the study of? It's the study of matter, and it's, you guessed it, changes. So matter, what is matter? You know, remember we said before it's just stuff? It kind of is, but matter actually has to meet two requirements. First of all, matter has to have, come on now, has to have mass. There has to have some mass to it. And then it also has to take up volume, take up space. So if it takes up space and it has mass, then it would be classified as matter. So you guys think about it. Are you matter? Yes, because you have mass and you take up space. Is air matter? A lot of times people think air, oh, but you know what? You can collect some air, put it in a bag, put it on a scale, and you can actually weigh it because it consists of air molecules and it does take up space. So yeah, air, contrary to what many believe, it is matter. So the question is, what would not be matter? Huh. You know what? I'm going to leave you hanging with that one. Okay, so we have to be able to measure the amount of space and the mass that it contains. So we use units, and so you guys remember we had introduced you to metric units. The basic metric unit for volume is liters, and for mass is grams. So we have to describe matter, guys. When we're describing with others, we use characteristics, those are called properties of that matter to describe it. We can have what are called qualitative properties or quantitative properties, and to kind of understand the difference. When you guys ever see words that you haven't seen before, you just kind of look at the kind of the root or the base of it. You see qualitative sounds like the word what? Quality. Quantitative, what does that remind you of? Quantity. So the difference between it, when you think of quantity has to do with numbers. Qualitative is without numbers. So qualitative or quantitative? Qualitative without numbers, quantitative with numbers. And once again, you guys remember why I kind of go here quick, because you guys have the option to just, pause the video. And so that's why, normally I wouldn't go this quick in class instruction. What might be an example of a qualitative, a qualitative property? Let's say you had here, we got this. How could you qualitatively describe it? What could you say? You could say it's a liquid. That would be a qualitative property. You could also say it's clear. You guys notice those were all properties. And then maybe if it had an aroma, a smell. And then, but the next one would be quantitative. How could I describe this quantitatively? Somebody might say you could tell the mass of it. Well, maybe I have about, let's say 50 grams of this, but you think about it, would that help you identify the substance? No, because you could have 50 grams of whatever. You could have 50 grams of Kool-Aid, 50 grams of water, you could have 50 grams of soda, whatever. So can someone think of as if you're going to respond, but you want to try to think of what could be a quantitative property that is with numbers that would help you to identify a substance. And you guys might have learned from middle school, there is something that is specific to each individual type of matter. Each matter has its own unique, starts with a D. Okay, you guessed it, density. Density is the mass compared to the volume, the mass to volume ratio. So water, for example, has a density of 1 gram per milliliter. So every 1 milliliter weighs 1 gram, and that's unique to water and would help us to identify a clear liquid as water, because not necessarily all clear liquids are water. Okay, so these are just different ways to describe. Somebody else might even mention another quantitative property might be the boiling point. You guys know what a boiling point is? The temperature at which it boils, or the melting point if it was a solid, right? And different substances have unique boiling point and melting points. So the specific kind of matter is identified by all its properties. Notice how many different properties I brought up just even for a simple type of matter like water, okay? When are chemists most interested in matter? You guys know. Remember, if matter's just sitting there, it's not very interesting, right? But chemists are interested in matter when it is changing. Okay, so that's what we're going to be talking about, chemical and physical changes. So, changes in matter always have an accompanying change in. Let's think about that. Whenever matter changes, guys, there's always a change in fact, I'll kind of get to this. You guys, the physical universe consists of two things. Everything in the physical universe consists of matter and what else? Give you a few seconds. Matter and energy. And so when matter changes, right, then also the composition of matter, when it changes, there's also a change in energy. Okay, so now we're getting to the crux of our lesson here today, the difference between physical and chemical changes. Physical change is a change in phase, or I might even say a change in state, and then that will probably help you. You guys are probably thinking, what are the states of matter? You're like, oh yeah, solid, liquid, gas, right? Okay, you guys, I'm going to give you guys a bonus. The next time we meet on our live session, the first person who can tell me what the fourth phase of matter is, I will give you some bonus points. Now, I will say this though, because I know some people have some background. They're like, "Oh, I already know the fourth phase of matter, and I know what you want to say." Especially if you had any kind of physics, you're going to say plasma. Plasma is when something has super high temperature, and it's not really even a gas. It's in a different phase. But you guys, this is it's not going to be plasma. It was plasma because you could Google that and come up with that really quick. But it's not that. It's something else that we use, especially when we're talking within the subject of chemistry. So I'm going to leave that hanging. If you guys know it, you guys figure it out, you guys find it out, let me know. I'll give you bonus points. Okay. So for example, what would be an example of that? Let's say I had some water, right? And I heat it up. You guys, what's going to happen to the water? You guys know. It's going to evaporate. But you guys think about it. What did I start with? Water, liquid water, H2O. And then when I heat it up, now it's a gas, but what is it still? It's still water. It's still H2O here, so you guys can kind of see. Here's what an H2O molecule would look like. See, one oxygen, two hydrogens. The only thing different is the molecules are more separated, and that's really the difference between a substance in the gas phase and the liquid phase, where the molecules are closer together. So in that case, it didn't chemically change. It was just a physical change, a change in phase. Chemical change, however, is when you form a new substance. So once again, a chemical change or a chemical reaction involves atoms rearranging, and you actually do form a new substance when there's a different arrangement of atoms. So then this is what you guys are going to be doing in an in-class lab when you return, is you guys are going to be figuring out, okay, you have to first of all know what is evidence that you would have that a new product, a new substance is actually formed. Okay, here's the first thing. If there is a dramatic change in energy, indicating an energy, right, light or heat, something like that. If a dramatic change in energy occurs, you're able to observe that. That's a good indication to you. That's evidence that a chemical reaction happened, that there was a rearrangement of atoms. You guys, here's a pretty simple one that we've seen before. I got paper, and you guys already know, what does paper react with? Don't say fire. You guys know paper reacts with oxygen. I just have to initiate the reaction, right? And so I provide just a little, but you'll notice, did I have to keep doing this? No. So where's that fire coming from? It's not coming from my my lighter. It's being produced, and you guys can see a lot of light and heat's given off here. Oops. And once again, that's an indication that indeed a chemical reaction is happening. And then you can obviously see the ash is definitely chemically different than the paper we started with. Okay, but once again, a lot of heat given off, good indication a chemical reaction occurred. Okay, here's another thing you could look for, indicating a chemical reaction or chemical change occurred. If there's an unexpected color change. Now, unexpected color change. You got to be clear here now, guys. Okay, think about this. Have you guys ever had those blue tablets? Did your mom or something ever buy a blue tablet and put it in the tank of your toilet? You know, and then it makes the toilet water blue. I'll tell you guys right now, if you've never peed in blue water, you've never really lived. And those of you guys who peed in blue water, you know what I'm talking about. It just feels more refreshing. You know, when you're doing your business and you're doing it in blue water. And you guys, those of you guys who've experienced that, you guys know, what do you guys notice when you urinate use the proper word. I'm a science teacher, right? You urinate in blue water. It turns green. You guys know that? Yellow and blue make green. It's like it's a beautiful like artistry going on there. Let me ask you guys, is a chemical reaction occurring? You'd say, yeah, it's obviously was yellow and blue and now it's green. No, because what does this say? You guys, keyword here is unexpected color change. You would expect, because you guys, whenever you get blue like urine has a yellow color to it, obviously, and then the blue from the tablet you put in your toilet. When you have blue molecules and yellow molecules together and they're mixing together, and then light's bouncing off that and returning to your eye and it's coming at the same speed, what does your eye perceive it as? It perceives as yellow. Doesn't indicate that there was any kind of chemical reaction occurring. It's an unexpected color change. It would be kind of like this. Let's see. Okay. Here I actually have some acid. And you guys see, that's why you can't just say a solution is a clear liquid and know it's water, because acids, which is basically a substance dissolved in water anyways. Okay, so I have my acid. You guys would describe it once again as a clear liquid. Here, we'll do a little bit. We'll do a little bit. Okay, so I have an acid here, and then here I have, I don't know if you guys can see it, it's called bromothymol blue. Well, you guys could guess, even if it's hard to see, it might just look black. But what color do you think it is? It's actually blue. That's why it's called bromothymol blue. Duh. Okay, I don't know if you guys can see it. It's actually bluish. I don't know if I can show it on it here. You know what? Just so I can prove it to you. Like I got my paper. I put a drop on that. You guys tell it's blue? I don't know. It looks kind of blue. But anyways, it's blue. Okay. So I take that and so I have a clear liquid and I have you would agree, a blue liquid, bromothymol blue, and then I put it in there, and all of a sudden it's what? Hopefully you guys can tell, it's orange. Obviously that isn't, you wouldn't expect blue and a clear to be orange. So what this is indicating, obviously there's something here in here now that wasn't there before, because I started with substances that were blue and clear, and now all of a sudden I have substances that reflect orange light, indicating that there was a rearrangement of atoms, a chemical change occurred. So that's what we mean by an unexpected color change. Okay. Okay, another thing you could look for, production of a gas. Okay, so for example, here we'll do another one. Okay, once again, I'm going to use my acid. This is hydrochloric acid, okay? Put it in my test tube. And you guys see, we often use test tubes for chemical reactions. Just, okay, once again, it's a clear liquid, okay? Then I'm going to get some zinc. Okay, so there's some zinc. You guys should know zinc's a metal. If you look on your periodic table, it's in the center of the periodic table. It's number 30. Okay, so I need to get like little small pieces of zinc. So I'm gonna get some small pieces of zinc here. And zinc is actually, you know, you guys, it is good if you don't know what it is you're dealing with to not handle it with your bare hands. But I know zinc's not toxic, and it's not gonna do any damage directly to my hands, so I can hold it. Okay, so now you guys look, I got my acid, and this is pretty typical of acids and a lot of metals. So this is just I just happened to get zinc. I could have got some other metals as well. But then I'm gonna add the zinc to the acid, okay? And you guys should be making some observation. I'm sorry guys, I don't know if I'm showing this right or not. Okay, I thought it would be a little bit more vigorous than that. You know what? Here. Let's see here. Okay, sorry guys. Hopefully you didn't fall asleep on me. You know what? It wasn't as dramatic as I wanted it to be. So what I'm going to use is, I'm going to use a slightly more concentrated, here. I'm going to use a slightly more concentrated acid just to get a better effect. Okay, I'm still going to Got some my zinc. Sorry guys for the little hold up here. I'm gonna put some zinc in here. Okay. Still got some zinc. Now this is the same kind of acid, it's just a little more concentrated. We'll talk about concentration later. Should have eye safety wear on, but it's here quicker. I think you guys can see it a little bit more dramatically. Now all of a sudden, you guys seeing the bubbles there? And what are bubbles an indication of? What's being produced there? A gas. Well, wouldn't you guys agree? Before all I had was zinc, which is a solid, and then I had hydrochloric acid, which was a liquid, and now all of a sudden I got this gas that wasn't there before. So obviously there had to be a rearrangement of atoms, and in fact this gas is hydrogen. Oh, some little something here. Check this out. Be kind of interesting for some of you guys. If you wanted to know what kind of gas was given off, okay, if this was carbon dioxide gas, and if I were to light this splint, and I was to put it in the carbon dioxide gas, what do you guys think would happen to it? Well, you guys, wouldn't it go out, right? Because you guys know when you guys blow on a candle at home, you're blowing along with your hot funky breath, you're blowing carbon dioxide, and it puts out the fire. Okay, so let's see what happens here. Let's see if I put that in. Now get it. Oh, you guys hear that? It's called a little pop test. And the fact that it did that, what do you guys think that tells us about the gas that's being generated in this chemical reaction? Let's see if we can get it again. You know what? That indicates that that gas is flammable. Does anyone want to guess? Anyone? Anyone? I can't hear you. Anyone want to guess what that gas might be? Some of you guys might know a flammable gas. It's actually an element on the periodic table. The lightest element, it's actually hydrogen. So hydrogen is often a gas given off when acid, like hydrochloric acid, reacts with a metal. Okay, so that would be an example of a chemical change, the production of gas. Lastly, almost done here, guys. Production of a precipitate. You guys, a precipitate's like kind of a fancy word for solid. I know it sounds different than what you guys, when you guys hear precipitate, you guys, some of you guys know that it actually means, you know, rain, precipitation, right? You guys heard that, right? In fact, some of you guys are smart. Yeah, most people say it's raining, but you smart guys, you're like in the break, during nutrition break, and you're around your friends, and it's kind of get moist, and drops start falling. You're like, you know what? It sure seems like there's going to be a lot of precipitation today. You guys talk like that? Hopefully you don't talk like that. But anyways, that's the precipitation that you guys are probably used to. But in a chemistry lab, it's kind of weird. I know it's kind of confusing. A precipitate actually indicates a solid being formed. Okay, so if you guys saw this in a chemical reaction, this might indicate. So anyways, here I've got potassium iodide. Okay, it's actually a solid dissolved in water. So you guys, if you guys describe it, you say, oh, it's a clear liquid. And this is actually lead nitrate. And this is also, hopefully you guys notice, it's also a clear liquid. That's potassium nitrate's a solid, and I dissolved it in water. So I have two solids that were both dissolved in water, but nonetheless, they're both right in the liquid form. Okay, so now you describe two clear liquids, and now I put it together, and let's see what happens. Bam! You guys see that though? Check that out. Okay, first of all, you're like, well, first of all, that's a dramatic color change, so that's also a number 2. But it actually, I know it's kind of hard to see, but it actually is the production of a precipitate. I know it still looks like a liquid, but in actuality, you guys know if you can't, like, you guys see the difference? Check this out. Where's that line? Oh, here. Like here, you guys remember that with the bromothymol blue? That we'd actually say it's transparent. You can actually see through it. You guys know what you call something when you can't see through it? It's kind of like, you know, the windows, you know, you guys know you have normally clear windows, but you guys know you wouldn't want clear windows in your bathroom, right? Because it makes you can look in and see you doing your business. No, we don't have clear windows. We have what are called opaque windows, right? It kind of prevents the light from going through, so, or at least from being able to see visibly. So if you guys see an opaque solution form, realize that that's actually solid particles in there. And what if you just let this sit, what's going to happen is the solid's just going to fall eventually. In fact, I had one that I did some time back. So this same one, after a few minutes, check it out. You guys see it? You guys see the solid? I don't know if you guys can see the solid there at the bottom. So it all came out as solution. And so a solid, and you guys see, we started with two liquids, put it together, now all of a sudden we have a solid. So obviously there was a rearrangement of atoms, a chemical change occurred. Okay, we're gonna finish up just with one last thing. I wanna make a slight a distinction between elements and compounds. You guys know if it's an element, you're going to find it on, I keep pointing to the periodic table. You guys should have always a periodic table ready for you. If you guys look on your periodic table, those are all the elements. So atoms of the same, all atoms of the same type, if they're together, we call that an element. So an element would be, for example, oxygen. But you guys know when you do oxygen, you guys know oxygen doesn't exist as O. You guys know how oxygen exists? They always exist as pairs. We say they're it's diatomic. But you guys see it's still called an element because all it consists of is 2 oxygen atoms. So here's a little thing, right? Okay, that would be like 2 oxygen atoms, and you know when I'm taking in oxygen, we're taking in molecules. Obviously, the molecule is not that big, of course, but 2 oxygen. Okay, but what would be an example of a compound is when you have 2 or more different types of atoms. Here would be one. So I'm breathing in oxygen. What am I breathing out, guys? Along with my hot, funky breath? You guessed it, carbon dioxide. But you guys see how that would be a compound because it's a combination of 2 or more different substances. So what would that look like? That's what carbon dioxide might look like. Carbon atom flanked by 2 oxygen atoms. That would be carbon dioxide. That would be a compound. All right, guys, that's all I got for you guys today. We will see you next time. Bye.